5.4, completing the square. Last few days, we've been dealing with solving problems like this. We had x squared minus 6x, and there was something else on the end. In these problems, something's missing. Completing the square, it's when you have that perfect square trinomial, where it was in the form of, you had the x plus a squared, which meant what? Right, and we break it apart. The form is x squared plus, not a, 2ax plus a squared. So what we're going to do is find out what's going to complete the square. And get a 6. 9. Why? Good. This number right here is going to be plus 9.
Please report to the office.
Some problems are easy to see. That one's plus 9. Here's this one. X squared plus 15x blank. What number square, or take the square root of what number and put it together, doubled, gets me a 15. That is a number. It's not going to be a whole number. So we need to find something that's going to work for every single time. And all we need to know is it's whenever I hit the markers. That's like having here a negative 6x. How do I get a negative 6 knowing that 2ax? Well, 2 times negative 3. So in other words, I take this middle term and cut it in half. And I get negative 3. I take this number and I square it, and I get 9. So it's plus 9. Right. Correct. So looking at the x squared plus 15x, take your middle term. The middle term that's attached to just the single x. Take 15 divided by 2. Okay, 7.5, we're just going to leave it as 15 halves. We're going to take this and we're going to square it. Take the middle term, square it. What's 15 squared? 225. What's 2 squared? 4. So what goes on the end here is 225 fourths. It's going to be harder to do that if I change that to 7.5, because what's 7.5 squared? You still got to change it back to improper in order to square it. Don't use decimals either. That's your answer. 225 fourths. Yeah. That's the same thing. But we don't want the decimal, we want the fraction. Shonda. Simplify it if you can. This is what we're going to use completing the square. Try to factor x squared plus 6x plus 16. I try to factor this one? Only way I can get an x squared is x times x. Only way I can get a 16. 1 16, 2 and 8, 4 and 4. Now the signs have to be same because of this, and they both have to be positive. So what am I going to do with my numbers? Add them together. Can I add any of those two numbers together and get a 6? No. This one cannot be factored using our usual ways. We're going to use completing the square. Take the 16, the last term, move it to the other side. So I have x squared plus 6x equals negative 16. We're going to complete the square. So look at my middle term. It is a 6. 6 divided by 2 is 3. Now I take 3 squared is 9. So I have x squared plus 6x plus 9 equals negative 16 plus 9. To do to one side, I have to do to the other. Bottom drawer. Now what do I need to do here to factor? Don't even worry about this over here. What do I get when I factor? It's a perfect square, so it's x plus 3 squared equals, what's negative 16 plus 9? Negative 7. Can we do one thing in this problem? Something's not going to work out. Well, why does that matter? Why do you have to take the square root? The x plus 3 is squared. So to get rid of the square, I need to take square root. Can I take the square root of a negative number? No. Just to make the problem easier for us to work with, go back up to the top, make this a negative 16. And the top, all you have to do is just change that plus. I'm doing it because I want this problem to work. So that would be a negative. When I move it to the other side, it becomes positive. So here it's positive. And what's 16 plus 9? 25. What's that? Now we can take it further and actually find out what my zeros are. You already told me to get rid of a square, I take square root. So after taking the square root, x plus 3 equals, it's plus or minus 5. Move the 3 over, so it's x equals negative 3 plus or minus 5. Now I can actually solve this one. What's negative 3 plus 5?
Negative 2.
2. What's negative 3 and 5? Or negative 5? Negative 8. My zeros are at 2 and negative 8. I had to go back and fix it. Because once I got down so far, I noticed that I couldn't solve it any further. This one would have no solution. I did it on purpose to fix it. No. Here, let's look at this one. Yeah. One thing about completing the square. It has to be x squared plus something x and then a constant. What? Yeah, you just have to rearrange. I can't have the 2 out front here. That causes me a problem. What do you mean by it? Divide the 2 where? To everything. That's going to be divided by 2. That's going to be divided by 2. That's going to be divided by 2. I divide everything by 2. So I'm left with x squared plus 3x equals 7 halves. Leave it as 7 halves. I want to complete the square. Take my middle term. Cut it in half. Well, it's 3 halves, right? I take that and I square it. What's 3 halves squared? 9/4. X squared plus 3x plus 9/4 equals 7 halves plus 9/4. Yep, and you put it on both sides. Now this one factored.
Teachers, please excuse interruption. I need to see the following people. Asia and
When I factor this, it is x plus 3 halves. Where did I get the 3 halves from? It's right there from where I squared it. It's always going to be that number that goes in there. Now what's 7 halves plus 9/4? You can use a calculator or do it by hand. What's the common denominator? 4. So to make this a 4, what does this become? 14. So what's 14 plus 9? 23/4. Now what do I need to do? Take the square root of both sides. X plus 3 halves equals plus or minus square root of 23 over 2. Why is it the square root of 23 over 2? Square root of 23. Use a decimal. We good? Next step. Go ahead. Square root of 23 over 2. What was that? Now I need to move over the 3 halves. X equals negative 3 halves plus or minus square root of 23 over 2. Leave it. Don't try to solve it any further. This is how you leave them. If you have a radical in the answer, leave it there. Don't take out the decimal. Are we good? That is the answer. Now I have x squared plus 10x minus 24 equals 0. Now whenever we're factoring and we're trying to find our zeros, first thing we should always try to do. What's the first thing I should try to do? Before that. Before that. Before you try to factor. What should you try to look? What's the basic type of factoring? Any common term. Anything in common between everything? No. After I've done that, can I factor this one the original way? I have a negative 24 and a positive 10x. Is there x minus 12, x plus 2? Good. it should be x plus 12, x minus 2. 12 times negative 2 is negative 24. 12 and negative 2 is positive 10. So what are my zeros? Negative 12 and 2. Those are my zeros. That's the old way. I'm going to show you the new way that it still does work. No, you shouldn't hear me on the microphone. It's turned off. All right. Move the 24 over. X squared plus 10x equals 24. To complete the square, take the middle term, cut it in half, which is 5. Now I take that 5, and I square and get 25. So I have x squared plus 10x plus 25 equals 24 plus 25. Factor this one. We know it has to be x plus 5. The 5 comes from here, the plus comes from here. Equals 24 and 25 is 49. Take the square root. X plus 5 equals plus or minus 7. Subtract over the 5. Plus or minus 7. Because I just have two integers, what's negative 5 and positive 7? Positive 2. What's negative 5 and negative 7? Negative 12. Those are my zeros, and you notice they're the exact same thing. Any questions on this? I know I could have. What this says is if I have y equals a times f of x, if I take a function and I multiply it, it does a vertical stretch. So it stretches it vertically, and it compresses it if it's a smaller number. What?
What is that, a vertical stretch? What do you mean?
You take it and you stretch it vertically, up and down. If I multiply it, it's stretching it up and down. If I have f of b of x, something is happening, you change something inside of the function. It is a horizontal stretch or compression. So in other words, horizontally it stretches it out or pushes it in. If I add a number to a function on the outside, it moves it up and down. If I add a number inside of the function wherever x is at, it moves it left and right. Notice that it's x minus h. So if it says x minus 5, that means I move it to the left 5, or sorry, to the right 5. If it was x plus 5, I move it to the left. what we're going to do now is we're going to convert to vertex form. We're going to find the vertex and the AOS. That's the axis of symmetry. That is the line straight up and down that cuts through the parabola. Yes? Completing the to do form, you have to change into completing the square. Here, I'll show you. I have g of x equals x squared minus 6x plus 2. Correct. I'm just going to put parentheses around the x squared and the negative 6x. Yep. It's always around the x squared and the negative 6x. And you can't have a number attached to the x squared. Take the middle term, divide by 2. Negative 6 divided by 2 is negative 3. I take that and square it and I get 9. So g of x equals, now put that on the inside, x squared minus 6x plus 9 plus 2 minus 9. Why did I put minus 9 instead of plus 9? What's different with this problem and they're on the same side? See, when we did this problem here, I had a 25 on this side and a 25 on this side. They canceled one another out. If I add a 9 inside and I'm still on the same side, I have to subtract it. So I really don't do anything. Yes, I know if I simplify, the 9's canceled out, but that's the point of this. d of x equals, when I factor x squared minus 6x plus 9, x minus 3 squared, what's 2 and negative 9? Negative 7. That is vertex form. Nope, that's it. That is vertex form. If I look at vertex form, it has to be y equals a times the quantity of x minus h squared plus k. Right. You have to divide everything.
But in the little form, it has an A out front.
Right, because you could pull something out of everything. Correct. I can pull something out of everything, but I can't leave it in there in front of that x squared. Right. HK is my vertex. What's a vertex? It's the lowest or the highest point. I have my graph. My vertex is at 3, negative 7. Why? Because the form for vertex form is x minus h plus k. So it's 3 and negative 7. Because in the original form, it's x minus h. That minus, if there was a plus there, that'd be a minus 3. So 3, negative 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. That is my vertex. AOS is x equals 3. You tell me where it came from. It's the line straight down through the vertex. And there you go. It's easy, just type it in your calculator. No, I'll get to it.
How did you find the AOS?
It comes from the vertex. It's x equals 3. I'm not done yet. There's my AOS. That's my vertex point. Give me a point before that. Give me 1. I don't want to be super close. I want to be a little bit far away. Even better would be 0. So I put 0 in for x. 0 minus 3 squared minus 7. That would be 9 minus, actually, I don't know why I put squared. 9 minus 7, which is 2. That means at 0, I'm up 2. Here's the nice thing about a parabola. How many spaces away am I from a vertex? 3. 1, 2, 3. It has to be a mirror image. This is where a lot of you want to just go and make a V. What graph looks like a V?
Those graphs we did already.
Yeah, those graphs we did already. Good. Absolute values. These ones are U-shaped. There's your parabola. What's that? I could put a dotted line down the middle. That's my AOS. The other side, it's a mirror image. It's symmetric. Right. See, that's the nice thing. You only need to pick one point because it's going to be a mirror image on the other side. Yeah. Yes. It needs to be used. It doesn't have to be perfect. I cheated. Right. I know. Are we good? I want you to try this one. On this problem, first thing we need to do, put the first two terms, the x squared and the x, in parentheses. Take the middle term, the x, divided by 2, and I get 4. I take that and square it and get 16. So I have m of x equals x squared plus 8x plus 16 plus 11 minus 16, which equals x plus 4 squared minus 5. I am done. What's my vertex? Negative 4, negative 5. 11 minus 16. The AOS is x equals negative 4. I am done. Yep. You take the opposite of what's on the inside of the parentheses. Yes, the AOS is always the x of my vertex, and that's your lesson.